All right, everybody, get ready, because today we're going deep, and I mean deep, into the world of the human heart.
Yeah, this is one of those topics, it's just incredible how much there is to learn.
It really is. I mean, we hear about the heart all the time, right? It's a pump, it keeps us alive.
Yeah.
But when you really get into it,
It's mind-blowing, a nonstop organ, just chugging along day in and day out. Did you know it beats about 100,000 times a day?
100,000. No wonder it's known as the engine of the body. That kind of dedication, makes you wonder about its design.
Absolutely. And it's not just placed randomly in there. It has a very precise location, and even the way it's positioned is fascinating.
Oh, you mean how it's slightly off to the left?
Exactly. You feel it more on the left side. And there's a reason for that. It all goes back to this area called the mediastinum. That's where the heart is.
The mediastinum.
Yeah, it's like this central compartment in your chest, nestled between your lungs. And the heart isn't just plopped in the middle. The pointy end, which we call the apex, that's angled towards the left side.
So that's why we feel it beat on the left. Makes sense.
Mm.
But it's not like just floating around in there, is it?
Good point. Can you imagine with all that movement?
Talk about a bumpy ride.
There's this incredible protective sac called the pericardium.
The pericardium. Tell me more.
Okay, so picture like a double-layered bag.
Okay, got the bag.
And it's filled with fluid. The outer layer, we call that the fibrous pericardium. It's tough, really fibrous. And it's anchored to your diaphragm, to the major blood vessels. Basically, it keeps the heart from bouncing around too much.
It's like a seatbelt for the heart, keeping it secure.
Exactly. Now, the inner layer, that's where it gets even more interesting. That's the serous pericardium.
Serous pericardium.
And this one, it's smooth, slippery. It actually has two parts. One lines the inside of that tough outer layer we talked about, and then get this, the other part actually hugs the heart muscle itself.
Wow, a bag within a bag. What's in the space between them?
Yeah.
That can't be empty, right?
You are on fire today. It's not empty, that space. We call that the pericardial cavity, and it's filled with a bit of serous fluid.
Serous fluid, what's that do?
It's like nature's lubricant. It lets the heart beat with almost no friction at all. Every single beat, the heart glides effortlessly within this sac.
Wow. That is amazing. It really puts into perspective, it's not just a simple pump.
Not at all. And just wait, it gets even more incredible when we get into the actual inner workings of the heart.
Okay, you've definitely got my attention. Let's talk about the inside. 4 chambers. Right. Why 4? Wouldn't one big chamber be easier?
You would think so, wouldn't you? But it all comes down to efficiency. Think of it this way. To get things done right, you need a system. And the 4 chambers of the heart, they work together in perfect sync, like a perfectly choreographed dance. Each chamber has its own job to do, and they pass the blood along, making sure it gets where it needs to go.
A choreographed dance, huh? So each chamber has its own moves.
You got it. Each one plays a crucial role. Let's break it down, starting with the right atrium.
Like atrium. Okay.
Think of it as the entry point. Imagine like a busy train station, right?
I'm picturing it. Lots of hustle and bustle.
The right atrium, that's where all the deoxygenated blood comes back to. After it's circulated through the body, dropped off its oxygen, now it's back for more.
Tired blood, ready for a recharge.
Exactly. And from the right atrium, it moves into the right ventricle.
Okay, so right atrium to right ventricle.
Uh-huh.
Is that where those one-way valves come in?
You're way ahead of me. The tricuspid valve. That's its job, to make sure the blood goes from the right atrium to the right ventricle, no going back.
A one-way ticket.
Precisely. Then the right ventricle, its job is to pump that blood up through the pulmonary valve, another one of those one-way doors,
Okay.
into the pulmonary artery.
And the pulmonary artery takes it to the lungs.
Yeah.
Right. For that oxygen refill.
Bingo. It's like the blood's pit stop. It picks up some fresh oxygen, and then it's back to the heart, this time on the left side.
So it's like a round trip.
You could say that.
Yeah.
So now we're at the left atrium. That's where the oxygen-rich blood comes in from the lungs through the pulmonary veins.
All right. The blood is all fueled up, ready to go. Where does it go from there?
Next stop, the left ventricle. But first, it has to pass through the mitral valve. You might also hear it called the bicuspid valve.
Wait, 2 names for the same thing. Why?
We love our medical terms. Don't worry too much about the different names. It's the same valve.
Okay, as long as we're clear on what it does.
Right. It basically lets the blood flow from the left atrium to the left ventricle, just like that tricuspid valve we talked about earlier.
Gotcha. So the left ventricle, what's its role in this whole dance?
That's the powerhouse. The left ventricle, it has the biggest job. It has to pump that oxygen-rich blood out to the rest of the body. And it's built for it, too, nice and muscular.
It's like the heart's weightlifter.
Exactly. It pumps the blood through the aortic valve, another one-way valve, and into the aorta, which is, the big kahuna of arteries.
The aorta, right. And that's the main highway for the blood to get all over the body.
You've got it. It's really quite impressive when you think about it, this whole coordinated effort. But there's another piece to this puzzle.
There's more.
Oh, yeah. We've talked about the chambers, the valves, but how does the heart actually know when to contract? What's the signal?
That's a good question. Does it just, like, decide when it's time?
That's where it gets even more amazing. The heart has its own electrical system.
An electrical system,
Maybe.
wait, inside the heart?
It sounds crazy, right? But that's how it works.
Yeah.
This is what makes the heart tick, literally. It's like, those domino effects where you line up all the dominoes,
Yeah.
you knock over the first one, and it sets off this whole chain reaction.
Right.
It's kind of like that. The electrical system sends signals through the heart, and that's what makes it contract at just the right moment.
Okay, so where does this electrical impulse, this signal, where does it start? What's the first domino?
It all begins with a group of cells called the sinoatrial node, or SA node.
The SA node?
Exactly. Think of it like the heart's own personal pacemaker. It's up there in the right atrium, sending out these little electrical impulses.
So the SA node sends out the spark, and then what?
Well, that impulse, it spreads through the atria, making them contract.
Okay,
And then it hits this other node, the atrioventricular node, AV node for short.
another node. And what's its job?
It's like a relay station. It takes that electrical signal, holds onto it just for a moment, and then passes it on to the ventricles.
Holds on to it. Why the pause?
Timing. It's all about timing. That little pause gives the atria time to finish contracting, to get all the blood out before the ventricles get the signal to contract.
Wow, talk about coordination.
Yeah.
So how does the signal actually get from the AV node down to the ventricles? Like, we need more dominoes to complete the chain.
That's a great analogy. And you're right, there's a pathway for that. It's called the bundle of His.
Bundle of His.
Yeah, it's like a little electrical highway, and it splits into two branches, one for each ventricle.
Okay, so the signal splits, making sure both ventricles get the message.
Exactly. And from there, the impulse travels down to the Purkinje fibers.
Purkinje fibers, all right. Last stop on the electrical highway.
You got it. They spread the signal throughout the ventricles, and bam! The ventricles contract, pushing that blood out to the body.
Wow. Just wow. It's amazing how such a tiny electrical signal can create such a powerful force. And all of this, we can actually see it happening with an EKG, right?
Absolutely. Electrocardiogram, it's like listening to the heart's electrical activity. Those little blips and waves on the screen, they tell us how the heart is doing, if the rhythm is normal, all of that.
It's truly incredible. So we've covered the chambers, the valves, this whole electrical system. But even with all this amazing design, the heart itself needs support, right? Like, it's got to get its own fuel and everything.
You're absolutely right. The heart works hard, and it needs a constant supply of oxygen and nutrients, just like any other organ. And that's where coronary circulation comes in.
Coronary circulation.
Think of it like the heart's personal delivery service. We've got the coronary arteries. Those are the key players. They branch off from the aorta right near the top and wrap around the heart like a crown.
A crown, that's a good way to put it.
And their job is super important. They deliver oxygen-rich blood straight to the heart muscle, keeping it fueled up and ready to go.
So even the heart needs its own blood supply. It's like a self-sustaining system. What happens to the blood after it's, delivered the goods to the heart muscle?
Good question. We've got to get rid of the waste, right? That's where the coronary veins come in.
The coronary veins.
They're like the cleanup crew, collecting the deoxygenated blood and sending it back to the right atrium to start the cycle all over again. It's a beautiful, efficient system.
It really is. When you think about it, this little organ, it's working constantly, from even before we're born. Speaking of which, I'm curious, when does the heart actually start beating?
This is one of the most fascinating parts of it all. The heart starts beating incredibly early in development.
Really? How early?
We're talking just a few weeks after conception.
Wow.
Yeah, like 3 weeks in, and it's already starting to form and function.
So how does it go from a few cells to this powerful organ?
Picture this. Right at the beginning, it's basically two tiny tubes.
Okay.
And those tubes, they fuse together, forming one primitive heart tube.
So it starts simple.
It does, but it doesn't stay that way for long. That little tube goes through this incredible transformation. It loops around, folds in on itself, and that's how those 4 chambers we talked about, they start to take shape.
That's amazing. It just keeps going from there.
Oh, yeah. It keeps growing, it adapts as we do. Over time, things might change a bit. The heart muscle might get a little thicker. The valves might not be as flexible as they used to be. But it just keeps on ticking, adapting to whatever life throws at it.
It really makes you appreciate the resilience of the human body.
Yeah.
And, I think this deep dive has really opened my eyes to the complexity, the power of something we often take for granted.
I agree. It's a powerful reminder to take care of ourselves, to make choices that support this incredible organ.
Absolutely. It's been an incredible journey into the world of the human heart. And to our listeners, we'll leave you with this thought. Take a moment and just listen to your own heart. What is it telling you? This has been another fascinating deep dive. Until next time.